Okay, so on this worksheet, we're going to be solving quadratic equations by factoring. Um, and make sure you show all work as presented in the videos. Okay, so now this is a quadratic equation. So, and these are in standard form. So one's in standard form, two's in standard form. So remember, standard form looks like this: ax squared plus bx plus c equals 0. Okay, so you're going to do just like you've been doing before, like when you were factoring. You're going to look for the GCF first. It does help you. Now, since this is an equation, and you forget to do the GCF, if you get to factor out the GCF, it's not going to really matter in the end. But if this was not an equation, and you were asked to find the GCF, I'm sorry, to factor only, then you would need to factor out the GCF. Alright, so I'm going to do it both ways to show you what I mean. But if you factor out 3, you can get 3 times x squared minus x minus 20. And then you factor this trinomial, you're going to get 3 times, let's see, that's going to be xx, 5, 4, and this last sign's negative, which means these signs are different. One's positive, one's negative. And so this one's going to be the negative, this will be a positive. And always check yourself, x times x squared, a negative 5 times a positive 4 is a negative 20. The outers are 4x, the inners are negative 5x, and we add them up, you get negative x. Then you're going to set each factor equal to 0. So remember, now you're using the 0 factor property, just like the previous worksheet. Alright, so you have 3 factors here. You have a factor of 3, you have a factor that's an x minus 5, and you have a factor that's x plus 4. This factor of 3, that factor does not contain a variable. So there's no way that, remember, the 0 factor property says that we have 2 or more factors whose product is 0, then one of those factors has to be 0. Well, if you look at this factor is never going to be 0. This factor is always going to be 3. So technically, you can just forget about this factor right here. And so all you have to fool with are these 2 factors. Those are the factors that contain the variable. This factor did not have a variable. All right, so you just forget about it. So these are the only 2 factors in which one of them has to be 0. Alright, so you said both of them equal to 0. And you solve for x. So notice you went from a quadratic equation to 2 linear. So I get x equal 5, and I get x equal negative 4. So those are your 2 solutions. So x equal 5, x equal negative 4. Now, the other way, which I wanted to mention to you, is suppose that you forgot to factor out the GCF. Alright, it's not going to matter at all, and you're going to see this because this is an equation. Now, if this was not an equation and just said factor, then yes, you would have to factor completely. Okay, so let's say this is 3x, this is x, and let's use for 60, let's use 15 and 4. So let's make, I think the 15 would have to go here. So let's make this 15 and this 4. And the outer is 12x. The inner is 15x. So that 15x has to be the negative. And this has to be positive. And always check yourself. 3x times x is 3x squared. A negative 5 times a positive 4 is a negative 60. The outer is a positive 12x. The inner is a negative 15x. And we add them up, you do get negative 3x. And so if you set each one equal to 0, because remember you have 2 factors whose product is 0, so according to the 0 factor property, one of them has to be 0. So either this one can be 0 or this one can be 0. And so I get 3x equal 15, divide both sides by 3, 3 divided by 3 is 1, 1 times x is x, so I get x to be 5, and over here x equal negative 4. So you see you get the same answer regardless of whether you factor out the 3 or did not. But if you get to factor the GCF, that's fine because you're dealing with an equation. Okay, the next problem, it is in standard form already, and the GCF is 1, so let's just go directly to the 2 binomials, xx, 3, 3, The last sign's positive, so the signs have to be the same. There would be the middle sign. All right, now notice, so I factor this correctly. So notice, though, that these two factors are the same. So only use one of them. They're the same. So you just say x minus 3 has to equal 0, so x is 3. So you only have one solution, x equals 3. Now, in college algebra, you're going to learn that this x equals 3 is also called a double root because it occurred twice. A double root. All right, and in terms of graphing, that's going to be important when you graph polynomials next semester. The idea of something being a double root. Okay, over here, now keep in mind I did say factor by solve by factoring, so you have to factor. You can't bring the 49 over, divide by 2, and then take the square root. That's another section. That's in the next chapter. So you have to do factoring. So it is in standard form already. So I get 2x, 2x, 7, 7. The last sign's negative. So one's positive, one's negative. Now notice that this right here is difference of two squares. So you could have recognized that, difference of two squares. And so you're going to get 2x plus 7 and 2x minus 7. And so using a zero factor property, so if I have these two factors who's brought it to 0, then one of them, either this one or this one, has to be 0. So notice I went from a quadratic equation to two linear equations. So I get 2x equals 7, negative 7 rather, and then divide both sides by 2. I get x to be a negative 7 halves. So that's one of your solutions. Over here, add 7 to both sides. 7 and negative 7 is 0. 2x equal positive 7. Divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. I get x to be 7 halves. So your solutions are x equal negative 7 halves, comma, x equal positive 7 halves. Or you can say x equal plus or minus 7 halves because they're opposites of each other. So a negative 7 halves and a positive 7 halves are opposites, so you can write it like this if you want to. All right, number 4. All right, so number 4 is not in standard form, so you have to bring it in standard form. So I'm bringing the negative 49x over, so I'm going to add 49x to both sides. Is technically what I'm doing. So technically I'm adding 49x to both sides. All right, so I get 7x squared plus 49x equal 0. A negative 49x and a positive 49x is 0. Okay, so factoring, I can factor out a 7x, so I get 7x times x plus 7. And always check yourself. 7x times x is 7x squared. 7x times a positive 7 is a positive 49x. All right, now, really you have three factors whose product is 0. See, 7 is a factor, x is a factor, and x plus 7 is a factor. All right, but if you want to think of 7x as one monomial, you can. So you can say, but it's really three factors, a 7, an x, and an x plus 7. So one of these has to be 0. So 7x equals 0, or x plus 7 equals 0. So over here, to get x by itself, I divide both sides by 7. 7 divided by 7 is 1. 1 times x is x. And then 0 divided by 7 is 0. So one of your solutions is 0. And you can check it, if you want to check it, to see if that's true. Check x equals 0. You go back to the original. 7x squared equal a negative 49x. So if x is 0, 0 squared, that's 0. And you want to see if that's going to equal negative 49 times 0, which obviously is 0 as well. All right, and over here you get x to be negative 7. And you can check negative 7 as well if you want to. So if you want to check x equal negative 7, you can. So you're going to say positive 7 times a negative 7 squared. And you want to see if that's going to equal a negative 49 times a negative 7. So using your calculator, negative 7 squared is a positive 49. 7 times 49 is equal to 49. Now really you don't need your calculator here at all. I'm hoping you see this. See, this is 7 times 49. Well, on this side, you have a negative. Well, first of all, a negative times a negative is a positive. So they're actually when you multiply this out and multiply this out, it's the same number. You can even see that that's going to be true. Here you have 49.7. You have 49.7, but negative 49, negative 7, but a negative times negative is a positive. All right, so your solutions are x equals 0, x equal negative 7. Okay, over here, the GCF is 1, so I'm going to go directly to the two binomials. Let's see, 5x and x. All right, now let's try for negative 12. Remember, the last sign's negative, so the signs in here are different. But let's just look at the absolute value for right now. The absolute value of 12 is absolute value negative 12 is 12. So I can use 4 times 3. I can use 6 times 2. I can use 12 times 1. I'm going to go ahead and use 4 times 3 first and see what happens. So I'm going to put the 4 here, the 3 there, and double check yourself. The outer is 20x, the inner is 3. Remember, one of them has to be negative, and one has to be positive. So the 20 is going to be positive because the middle term is positive. So a 20x and a negative 3x is 17x, which is what you wanted. So this has to be positive and this has to be negative. All right, you have two factors whose product is 0, so one of them has to be 0. So you set them equal to 0. And so I get 5x equal 3. And so dividing both sides by 5, I get x to be 3/5. Over here, x equals negative 4. So your solutions are x equal negative 4, comma, x equal 3/5. All right, over here, this is already factored. It's already factored because really this means 3x minus 5 times 3x minus 5. And so that looks very similar to number 3. Look at number 3. It looks very similar to number 3. Remember when the two factors were the same? I'm sorry, wrong one. Number 2. Remember when the two factors were the same? You just use one of the factors. Same thing here. Just use one of the factors. Don't do it twice. Don't list them twice. List it once. So 3x minus 5 equals 0. Adding 5 to both sides. So notice you went from a quadratic to a linear. So combine like terms, you get 3x equal 5. And then to get x by itself, you can divide both sides by 3. Divide both sides by 3. And so you get x to be 5/3. So your solution is x equal 5/3. Okay? Alright, so that's the key to worksheet section 6.6, part